Determine if the system is inconsistent or dependent. If the answer is dependent, find the complete solution, write x and y as functions of t by letting z equal t, where t is any real number. To begin, let's label the equations to keep things organized. We'll label the equations a, b, and c. For review, recall, when we solve this type of system, there are three possible outcomes. We could have one solution, we could have no solution, or we could have infinite solutions. If the system has no solution, the system is inconsistent. If the system has infinite solutions, the system is dependent. And now let's solve the system using the method of elimination. Notice equation B only contains the variables x and z, which means we can shorten our work by using equations A and C and eliminating y to get a second equation in terms of x and z. And then we can solve that system of two equations and two unknowns to determine whether we have an inconsistent or dependent system. So focusing on the y terms of equations A and C, if we want to eliminate the y terms by adding the equations together, we want the y terms to be opposites, which means in equation C, we want the y term to be positive 3y. Right now it's positive y. This indicates our first step is to multiply equation C by 3, and then we'll add equation A. Let's indicate this by equation A plus 3 times equation C. Equation A remains the same. And now we multiply equation C by 3, which gives us negative 9x plus 3y minus 12z equals 3 times 15 is 45. And now we add the two equations together. Notice the y terms simplify to 0. We have negative 7x minus 21z equals 77. Let's go ahead and label this equation D. And now we're going to use equation D and equation B and solve the system of two equations with two unknowns. So we have equation B, which is x plus 3z equals negative 11. And we have equation D, which is negative 7x minus 21z equals 77. Let's eliminate the x terms. To eliminate the x terms, we want the x term in equation B to be positive 7. So now we'll multiply equation B by 7 and then add equation D. So we'll have 7 times equation B plus equation D for the next step. 7 times equation B is 7x plus 21z equals negative 77. Equation D remains the same. And now we add the two equations together, but notice both the x terms and the z terms are opposites. Adding the two equations together gives us 0 equals on the right. We also have 0. 0 equals 0 is always true, which indicates the system has infinite solutions. And if the system has infinite solutions, we now know for part A, the system is dependent. If we had something like 0 equals 2, which is never true, the system would be inconsistent and we'd have no solutions. And now we're asked to express x and y as functions of t by letting z equal t. For the solution, we know z equals t. The question is, what would x be in terms of t and what would y be in terms of t? Let's first write x as a function of t using equation B, which is x plus 3z equals negative 11. So using x plus 3z equals negative 11, if we solve for x, we have x equals negative 11 minus 3z. But remember, z is equal to t, and therefore we can say that x is equal to negative 11 minus 3t. And now to write y as a function of t, we need to use either equation A or equation C. I'm going to go ahead and use equation C, which is negative 3x plus y minus 4z equals 15. We now need to solve this equation for y, but also substitute negative 11 minus 3t for x and t for z. which gives us negative 3 times negative 11 minus 3t plus y minus 4t equals 15. Let's clear the parentheses by distributing negative 3, which gives us 33 plus 9t plus y minus 4t equals 15. 9t minus 4t is 5t. If we subtract 5t on both sides, we would have 33 plus y equals negative 5t plus 15. For the last step to solve for y, we subtract 33 on both sides, which gives us y equals negative 5t plus 15 minus 33, which simplifies to minus 18. So we have y equals negative 5t minus 18, or if we want, y equals negative 18 minus 5t. Again, we have an infinite number of solutions, but we also have x, y, and z expressed as functions of t, where t is any real number, which is much more powerful than simply stating we have infinite solutions, because this does show the relationship among x, y, and z. And sometimes you'll also see this expressed as an ordered triple, where the x-coordinate is negative 11 minus 3t, the y-coordinate is negative 18 minus 5t, and the z-coordinate is t. I hope you found this helpful.